For today's lesson, we're going to learn how to factor quadratic trinomials in a very special form, x squared plus bx equals c. Take a look at your lesson preview. F of x is equal to x cubed minus 2x. Now, you can see that it is a cubic binomial, and if we were to factor the GCF out of our cubic binomial, we have 2x times that 4x squared minus 1. Now, we want to determine where f of x is equal to 0. You can see that there are 1, 2, 3 answers. So 3 answers, let's see if we can find them. We'll take 2x and set it equal to 0. That tells us x is 0. Our other factor is 4x squared minus 1. When that equals 0, let's see here, we get 4x squared equals 1. Divide by 4, x squared equals 1 over 4. And you know from previous work that x is going to be equal to plus or minus the square root of 1 over 4. And the square root of 1 over 4 is 1/2. So there you can see where the 3 different answers came from. Positive 1/2, negative 1/2, and then x is 0. For our last problem here, we're determining f at 1. Remember, f at 1 is your x value. And we're going to take 1, substitute it into our function. F at 1 equals 8 times 1 cubed minus 2 times 1. Simplify, and you get 6. F at 1 is equal to 6. Check it out. If I substitute 1 into our equation, do we get 6? All right, looking at the next one. We have g of x is equal to 2x squared minus 3x plus 1. If we want to know where g of x equals 0, we're going to set our function equal to 0. So this again is where we're going to cross the x-axis. Looks like our answers should be x equals negative 1 and 1.5. Let's check. 2x equals 3, so x equals 3 over 2. There's your 1.5. Subtract 1, x is negative 1. Okay, so our next step is to write g of x as a polynomial. Right now, it's not a polynomial. If we multiply the x times the 2x times the x, we'll get 2x squared. Then we multiply 2x times 1. That's plus 2x. Multiply, we get negative 3x and negative 3. So our polynomial is going to be equal to 2x squared minus 1x minus 3. So to multiply that polynomial, we get 2x squared minus 1x minus 3. Characterize g of x. It's a quadratic because it's to the second power, and it also is a trinomial because it has 3 terms. For the last part of the problem, find g at 0. That is your y-intercept. Okay, so get warmed up, multiply questions 1 and 2. And when you multiply questions 1 and 2, think about the actions that occur, especially think about your middle terms. And then check your work. So let's focus on your multiplication. Notice, when you multiplied a binomial times a binomial, you had to first multiply your x times x to get your x squared, and 3 times 2 to get a negative 6. These middle terms were combined together so that you have a trinomial when you're finished. So our goal for today is to actually undo all of those operations. And when we look at number 2, similar things happened. You multiplied to get your x squared, and then at the end you had your 6xy. So those might be easy to figure out, but this middle term is a combination of the 2 things that occurred at the end. So let's talk about factoring these trinomials. X squared. So x squared came from the x times the x. Since we know that x squared is made up of x times x, and we know that our trinomial came from 2 binomials, x times x, we're going to move one of the x's into the first position and the other x into our second position. The 6 is a little trickier. 6 is 1 times 6 or 2 times 3. We're going to have to figure out how to get the 2 and the negative. Oh, a negative. So we really don't have 6, we have a negative 6. We want to get negative 3 and positive 2 back. Well, look closely. Positive 2, negative 3 gives us negative 1. If I were to think about my 1 and my 6 and subtract them, I would get a 5. Or I'd get a negative 5. So one of those two answers. And if I look at 2 and 3, I'm either going to get a positive 1 or a negative 1. Now think about what I want. I want a negative 1. The only numbers that are going to give me a negative 1 are positive 2 and negative 3 combined together. So we're going to write plus 2 and negative 3. So if you check your answer, wait, we're back where we started. X minus 3 and x plus 2. Let's try to get this one to go backwards. All right, so this time, trinomial, draw my two sets of parentheses. X squared, we're focusing on that. X squared is x times x, not so bad. 6y squared, all right, so we have 6y squared, that's what we want to get. We could have 1y or 6y. We could multiply 2y or 3y. This time, we want to think about adding our terms to get a positive 5. So if I add 1 and 6, I don't get positive 5. But if I add 2 and 3, I get my positive 5. So this is positive 2y and positive 3y. Check your answers. Where are we going to check those middle terms? 2xy and 3xy. And 2 plus 3 add up to give me that 5 that I'm looking for. All right, so we're trying to go backwards. This time, I didn't tell you the original problem. But I do recognize it is a trinomial. So I'm going to draw two sets of parentheses. I'm going to look at my x squared. Well, x squared is x times x. All right, so those are my only choices for the first part of my problem. The 10 gives me lots of choices. 1 and 10, 2 and 5. Okay, maybe not lots of choices. Here, I must add. That's what that plus sign says, add. And what do I want to get? I want to get a 7. So I add to get a positive 7. All right, so I'm going to add. All right, 1 and 10 do not work. Positive 2, positive 5, that will work. So we have x plus 2, x plus 5. Now to check your answer. We only want to check those middle terms. Is positive 2 times x plus positive 5 times x going to equal that 7 that I wanted in the middle? Yes. So my final answer are the factors x plus 2 and x plus 5. We're going to factor trinomials. This is a good example too. Once again, it's a trinomial and it's quadratic. All right, so I know I'm going to draw my two sets of parentheses. I look at my x squared. X squared is x times x. I fill in x, I fill in x. I look at the number 18. 18 is 1 times 18, 2 times 9, 3 times 6. So now we have to figure out, am I adding or am I subtracting? And right here, this sign tells me that I will subtract. But what do I want to get? I want to get a positive 3. So look at your list. Is there any way that I can subtract a 1 and 18 to get a positive 3? No. 2 and 9? No. Aha! This next one. Negative 3 plus 6 gives me positive 3. So I have x minus 3 and x plus 6. We're going to check our work. We always check. We get negative 3x, positive 6x. That does give me the 3x that I'm looking for. So my two factors are x minus 3 and x plus 6. Example 3, a little bit fancier, but still a trinomial. Draw two sets of parentheses. What times what is x squared? X squared is x times x. We're going to write our x, we'll write our x. Now we look at the 36y squared. All right, 36y squared. We know there's going to be a y. Let's throw that in there. There we go. Factors 1, 36, 2, 18, 3, and 12. So you do need to write all of your factors until you find the right one. I generally think about the ones on the bottom first, but you will have to figure that one out as you go along. This tells me to add, and what do I want to get when I add? I want a negative 15. Ooh, negative 15, huh? So if I add and get a negative, that means that both of these should be negatives. So as you look, you can see that the only pair of numbers that are going to work are negative 3 and negative 12. And you know what we do next? Of course, we're going to check it. Our middle term, we have negative 3xy, and our other middle term is negative 12xy. Those do combine to give me a lovely negative 15. So my two factors are negative 3y times x minus 12y. Give question number 3 a try and see what you come up with. Check your answer, of course. Oh, tried number 4. Let's look at example 4. So we're going to factor. Notice this is a trinomial. But is this a quadratic trinomial? No, this one's fancier than that. It has a GCF. So when you factor, you should always look for that GCF first. Notice it has a 3x. We're left with x squared plus x minus 20. And you'd think we would be done, but look inside that factor. Don't we have a trinomial? So the trinomial is going to be factored again into two more parts. Keep that 3x in front. Let's see what we get for our next part of the problem. Okay, x squared. We've been practicing. X squared is x times x. There we go, x and x. The 20. When we look at the factors for 20, 1 and 20, 2, 10, 4, and 5. What do we want to do? We want to subtract, and we want to get a positive 1. So one of these signs is positive, one of these is negative, and let's see here, positives and negatives. Which ones can we subtract to get a positive 1? You were right, negative 4 and plus 5. So this one had three factors, 3x, x minus 4, and x plus 5. 3 factors. Now there was a clue to tell us that there were 3 factors. Did you notice that this was x to the third as the lead coefficient? X to the third and 3 factors. Are we surprised? No. So to factor a trinomial in the form of x squared plus bx plus c, draw those two sets of parentheses. Factor that first term, factor your last term, determine which factors the last term will add or subtract to get that middle term. Write your factors in the parentheses and always check your answers. So give these problems a good try and check your answers in just a minute. As you review your problems, double check that you have the minus with the 6 and the minus with the 1. Double check that you're negative 7 and positive 1. It doesn't matter if you write it as x plus 1 times x minus 7, but the minus sign must go with the 7 or the 1. All right, working on question 6, and then number 7. I'll give you a little hint. See the cube? That is a hint, but there might be 3 factors. Look for that GCF first, and then see what happens. Number 7, make certain you factor out your GCF of good old 5y, and notice you have a trinomial that needs to be factored. Write these factors down. Do not try to skip this step. Write them out so that you get practice, and of course, check your answers. All right, number 5, things are getting a little bit stranger here. Notice it has x to the 4th. Now, if you have x to the 4th, you could have 4 factors. So let's see what happens. You could have. Notice the words I'm using. So we're going to draw our parentheses because it is a trinomial. Now think about x to the 4th. X to the 4th is x squared times x squared. So we're going to put in x squared and x squared. Think about 24. You just factored that. You should have lots of lovely factors. Use the ones that you used up ahead. You know that we're going to subtract to get a negative 10. So we're going to have a minus 2 and a plus, plus 2 minus 10, 12. There we go. And you look at your problem. I'm not seeing more factors. I just see x squared plus 2 and x squared minus 12. I don't see GCFs or more trinomials. Leave it alone. Here's another fancy problem for you. Take a look. U plus v is squared, and then we have a u plus v. So it is a trinomial. It's just a bit bigger. So if you have u plus v quantity squared, think about how to make that. U plus v times u plus v. That's just that definition of your squares. Let's write in u plus v in parentheses and u plus v in parentheses. Now think about the number 6. 6, 1 times 6 and 2 times 3. Which ones will add to give you a 5? All right, you guessed it, plus 2 and plus 3. Plus 2 plus 3. You should probably check this one since it's a bit crazy. Do we get 2 times u plus v and 3 times u plus v to add up to give you 5 times u plus v in the middle? And yes, you do. So we now have our two factors, u plus v plus 2 times u plus v plus 3. So there we have some factors, and those are trinomials. Work on this page, and I will answer a few questions for you in a moment. Okay, worked out a couple of problems at the top, but now let's look at these word problems. You're told that the area of the rectangle is represented by this polynomial expression. But you know that the area is length times width. The length was given to you, written it on the rectangle. You should do the same. Now, we know that the length is x plus 6. Can I find something to factor with the 12 to give me a 6 that adds to an 8? And yes, I can. So if the length is x plus 6, then the width must be x plus 2. And if we look at number 53, it's a very similar problem. We want the dimensions of the closet before it's constructed, but we know its area is length times width. So make certain you factor this problem, and you're going to be able to find the dimensions of your closet. And how many feet will the length and width increase after construction? So let's give this a try, following similar ideas. Okay, so for this last set of problems, number 77, you should begin with x squared, 81 is 9 times 9. And you're left with x squared plus 9 times x squared plus 9. Now if you were to try question number 80, let's look at that one. You have your u plus v and your u plus v. The factors of 3 are 1 and 3, so it's going to be plus 3 and minus 1. And those factor very nicely. All right, give some more of these a good try.